Hi, I'm Debbie Nelson with Nixene Publishing and Adrian Nixon, and I have been doing a series of videos about graphene. Adrian's coming to us from Yorkshire, England. I'm here in the United States. Hi, Adrian. How are you doing
Hi.
today?
Very well, Debbie. Nice to hear from you again.
You too. I'm looking forward to this segment because we're talking about something really unique, which is graphene ink. And I'm hoping that you can explain to us how this works, and especially with sensors.
Right. To do that, I think I'm probably going to have to share my screen and talk over some slides, if that's okay.
Great. Yes.
Good. So this graphene ink is powdered graphene solid that is ground up into nanoplates, or it's called exfoliated, if you remember from some of the early videos. So we've got tiny pieces of graphene, but these aren't in a powder, they're in a liquid form. Now, you're probably wondering, Debbie, how they keep something solid in a liquid form.
Yes, we've talked about dispersions before, so is this something special too?
This is a dispersion, yes.
Uh-huh.
What a dispersion means is it is something solid in small particles that is evenly dispersed throughout a liquid. So that's how you can think of a dispersion, whereas a solution is something like salt or sugar that you would dissolve into water and the solid disappears and goes into the liquid. Here, the solid doesn't disappear, the small particles still remain, but the trick with the dispersion is that the solids and the liquid don't settle out. So you can imagine if you just mix sand with water and give it a shake, very quickly all the sand goes to the bottom of the bottle and the water's on the top. With a dispersion, it's almost as if you just gave the sand and the water a shake and it stayed in that mixture forever, or at least a long time. It doesn't quite work that way with sand, because sand particles are still quite big, but with very small particles like graphene, then they can be dispersed in liquid, and they use what are called surface active agents or surfactants, a little bit like the washing up liquid you'd use at home, but more sophisticated versions of that. And they help the solid graphene mix intimately with the water and remain stable. Does that make sense?
Yes, it really does, because that gives it the even covering. Once you put this liquid down, it's going to be an even covering of the graphene, right?
Exactly, yes. And that even covering, then first of all, when you create a trail for the water to come away, and then you're left with a conductive trail of solid graphene on the surface. And that's roughly how these graphene inks work.
This is really interesting. So then now you have this printed on, how do you make it work?
Okay. So what the picture you're looking at in a minute, this was some of Vasarian's Graphene Ink, and they were a sponsor of something called the Graphene Hackathon, which was basically, it's a problem-solving challenge or an invention challenge for lots of smart people to come together at the Geek, and they create a project or product from scratch. So they have to create a working prototype that includes graphene, and this time it was graphene inks that needed to be used. So these inks that you see on screen were used by teams of people to create, in this case, mainly sensors, but lots of other applications. And the way that they work, if I move on to the next slide, you'll see here. This is a picture of one of the guys working on a graphene sensor at the hackathon. And can you see this white piece of fabric here, Debbie, with the pattern on it?
Yes.
So what they've done here is they've created it's called screen printing, but they've created a pattern, basically lots of little holes in a mesh. And then you squeegee the graphene ink on the surface, and it goes into all the holes and then goes through onto this fabric, in this case, creating this sensor array pattern on textiles. It's then dried out, and then you're left with the sensor pattern. And then what they've done here is they've stuck copper strips onto the surface of the textile in contact with the ink, and then connected it up through onto a circuit board through to something like a Raspberry Pi computer. And now you've created, in this case, a pressure sensor with graphene ink. So you just paint a circuit on and it works.
That's fantastic. Applications of something like that are extraordinary.
Yeah, and the whole purpose about the hackathon was to put a bunch of smart people in the room and give them these inks, give them the computing power, give them all the toolkits and everything, and see what they came up with. In this particular case, this team came up with putting the sensors into a seat. Now, this doesn't look like rocket science, but it is actually rather clever. This is a very crude prototype, but what the team only had 24 hours to put this together and test it and make sure it works and come up with a business case about why it should work. And this team did rather well. So you can see here that they've printed these sensors onto the seat part of the chair and then connected up all these circuits. Can you see the copper circuits just through the fabric, Debbie?
Can see that. It looks like stripes in the fabric.
Yeah, these are conductive trails of copper. So this is sort of self-adhesive copper which goes onto the fabric and connects up to the graphene. And here you can see a close-up of showing them how they work. So what all these sensors do here, the graphene bit here is responding to pressure. So when somebody sits down on the seat, then it deforms the sensor, and that changes the way that an electric current passes through it. So you can actually use this, that change in current, to work out how somebody is sitting in the seat. In this particular case, the business case was that the team would use this as a seat that could be built into a seat of a truck for long distance lorry drivers. And it would tell them if their posture was changing and they were getting into bad habits. So a warning would come up and then they'd be alerted, so just to improve their posture, which I think is quite a clever idea.
It is a clever idea. And with it being on the fabric like that, then you have that flexibility so that no matter which way you move and or how you shift your body, it's going to pick up the sensor.
Yeah, so I'll stop sharing there. That's how graphene inks work, and what's just a small example of what you can do with them.
Yeah, that's really fascinating when you start thinking about wearables. Talk about that a lot.
Yeah,
so,
maybe we should cover that.
Sounds great. Adrian, thank you so much for explaining this to us. This is fantastic.
Pleasure, Debbie. It's fun as ever. Bye-bye.